Hello everyone! In this video we are going to talk about fatigue damage spectrum, an option in our software which allows us to represent vibration impact in a such way that it would reduce the test duration by several times. Let's start with theoretical basics. And before we go to fatigue damage spectrum, I need to explain what is fatigue. Fatigue is an accumulation of damage caused by stress, which is the result of vibration. The accumulation of damage changes the properties of the object, causes the appearance of cracks, and eventually destroys the object. The ability of the object to withstand stress is called durability. When we deal with a prolonged vibration impact, durability is usually characterized by S to N curve, whereas S is stress and N is cycles. In this graph you can see how much stress cycles an object can survive when a certain force impact is applied to it. For example, an object can survive 10 cycles at 300 megapascals level or 1000 stress cycles at 200 megapascals level. Here in the screen you can see a Pilgrim minor rule where a lower n represents number of cycles with the ith level of stress, upper n is the number of cycles needed to destroy the object, and C is a number which characterizes the accumulated fatigue. When C gets the value of 1 or more, the object breaks. Now let's continue with fatigue damage spectrum. The fatigue damage spectrum shows the damage done to the object under test by a particular signal frequency. If power spectral density is the distribution of energy by frequencies, fatigue damage spectrum is distribution of damage by frequencies. Such spectrum is calculated by the same principle as a shock response spectrum. We take a number of spring mass systems, each with its own natural frequency. The system should have the same damping factor. A certain signal affects the spring mass systems, and calculate the damage level using the Pilgrim minor rule. In other words, to perform a fatigue damage spectrum test, we need to calculate fatigue damage based on the recorded data, and then synthesize a signal which would produce the same damage in a shorter time. So, as you see, fatigue damage spectrum can solve multiple problems. It can decrease the vibration test time, it helps to find and test durability of an object, and certainly gives an improvement in structural design and research quality. So, now let's continue in test tab. We open random test and create a new test. After that, in Profile tab we select Fatigue Damage Spectrum option. Here we see our main settings window. First of all, we need to select our VFX data recording files. Let's open these files. Now they are opened and on the graph you see their spectrum. Today I will use the road shaking recording and another random test recording. These files have different spectrums. Here you can also change their duration. After we have selected our date recordings, we need to set the calculation parameters. We select start and end frequencies in Hz, select the octave part for analysis, and set two main coefficients, B, which represents S to N curve, and Q, which is a Q factor. These coefficients can be found in reference literature or reference manuals. Now we are ready to add final parameters for the test. In the bottom of the window, we need to enter the time period for the test run. Let's set it as 10 minutes. And next to each date recording, we see a time text box. This time represents the time period we want to replicate. Let's set our road shaking to 4 hours and our random test will have the same duration. As a result, we get a random test profile which will simulate a long vibration test in 10 minutes. And after all these steps, we can press Recalculate Fatigue Damage Spectrum button. After this action, you will be able to see the resulting spectrum profile on the graph. Now let's press Calculate Power Spectral Density, and after that create Test Profile. So now we can see all the profile lines of our generated fatigue damage spectrum random vibration test. So in this video I showed you how to create a fatigue damage spectrum random test profile. That's all for today. Thank you for watching. Goodbye.